This is problem 4 from the exam review worksheet. And in this problem, we have the register below can hold its value or load a new value in parallel. Draw a similar register that can hold its value or shift right with serial input SEER in and serial output SEER out. So in this problem, we'll review a little bit about registers and parallel and serial and shifting. So, and multiplexers and D flip-flops. So all of those things are in this one. So let's first analyze how the register given works. It said it can hold its value. So first it has to choose, the multiplexer will choose between the 0 input and the 1 input, and it will do that based on the select input, which here is a variable called yellow. So that's just a variable. And if it equals 0, then the output of the multiplexer, and therefore the input to the D flip-flop, is the input into the 0 of the multiplexer. So if yellow is 0, then the multiplexer will have as output the input into the 0 input of the multiplexer. And if we look for each flip-flop and multiplexer combo, we have that the 0 input to the multiplexer is the output from the D flip-flop. And so it's going to hold its value because the output becomes the input. So whenever the value of yellow is 0, then the multiplexer chooses the 0 input, and that input is the previous output. So it just holds its value. So that's when the input, when the select is 0. Now when the select is 1, the multiplexer will have as its output the 1 input. And so if we look at each multiplexer, it has R0 for 0, flip-flop, R1 for 1, and R2 for 2. And so it's loading in parallel, and that means that each time it loads, it's getting each multiplexer and flip-flop is getting its own new value. It's not shifting from one flip-flop to the next. So just in parallel means they're all getting something at the same time. So it's parallel. And that's if the select input is 1. So what we're supposed to do is similar. We're supposed to have something that can hold its value, or shift right with serial input in and serial output out. So serial means that the value for register 2, the output for register 2, will become the input for register 1. The output for for flip-flop 2 will become the input for flip-flop 1, and the output from flip-flop 1 will become the input for flip-flop 0. And so Q1 becomes Q2, Q0 becomes Q1, and at either end we have a serial input coming into number 2, and we have the serial output coming out of 0. So let's try to draw this register. So with our registers, we know that we are always going to have a flip-flop, usually a D. It makes the most sense and it's the easiest one. So we'll have 3 edge-triggered D flip-flops. Two, 1, and 0, each with their output and input. And we have a clock. And the way registers work is each flip-flop is going to be associated with a multiplexer. So we'll put a multiplexer with each flip-flop. And each multiplexer will have a 0 input and a 1 input. And the output for the multiplexer will be for its associated flip-flop. Each multiplexer also has to have a select variable to tell it whether it's going to have the use the 0 input or the, I can't shrink that, yeah, there we go, whether it's going to use the 0 input or the 1 input. So we're going to have a variable. In the example it was called yellow, so we'll just call it yellow. And this variable can take on the value of either 0 or 1. And just for convenience for the diagram, this time we'll draw the select input on the bottom. Last time we drew it on the top. So the value here will tell the multiplexer whether the output should be the 0 input or if the output should be the 1 input. So one of the things it's supposed to be able to do is hold its value. So it'll hold its value the same way the example did. So we'll say it'll hold its value when the select input is 0. It doesn't tell us which it has to be, but that makes sense. So 0 to keep the same value. So that means its output will go into the 0 input, and so when the select is 0, the output will be the 0 input, which was, or the output from the multiplexer, which becomes the input for the flip-flop, is the output from the flip-flop, so it just will hold its value. Okay, so now we need to have it shift right if the input is 1. So if the select input is 1, we want the value that's in, we want Q1 to become Q2, and we want Q0 to become Q1, and we want what was Q0 to become serial output, and we want a new variable, serial input, to go into Q2. So let's start by having Q2 go to the 1 input of Q1. So now if the variable yellow is 1, then the output of the multiplexer is the 1 input, and the 1 input is the output of Q2, and so then that will be the new value of Q for this flip-flop. Similarly, for Q0, we would like its input to be the previous value of Q1. So if the input is 1, Q0 becomes Q1. Now we want the output of Q0 to be a new variable we're calling serial out. And we want the input for Q2 to be a new variable we're calling serial in. So this one is different than one we saw earlier, where we had the output from Q0 come around and become the input for Q2. Because you can do that too, but this is just a serial, so we get a new one coming in each time, and then it shifts right, and then the old one shifts out. So if we had originally the values of Q2, Q1, Q0 of 1, 0, 0, and then the input is 1, so that'll tell it to shift right. We have to have a variable serial input, and that could be 1 or 0. Let's make it 1. So Q2 becomes 1, Q1 becomes the old Q2, Q0 becomes the old Q1, and serial out becomes the old Q0. So everything is shifting to the right with the new value coming into serial 1 and the old value of Q0 coming out.